Hello, my name is Kevin, and today I will be teaching you how to find intervals that are increasing and decreasing for a function of x. So we'll start off with a graph. Now, as you can see, this graph is a poorly drawn parabola, but it's still a function. So let's pretend this is a little curve. So what we are going to do is define intervals where, in this function, as the graph shows, where it is increasing and decreasing. Now, to tell this is by looking at the y. Even though the y's are not marked, you can tell that this is increasing because the y itself is increasing. You're only looking at the portion that you have. So the y is increasing from this point to that point. Well, actually, it's from to infinity because you do not have endpoints here and here. You have arrows, so you can say that it's going from infinity. So from increasing, for this graph, we would say that the interval which this function is increasing is from negative infinity to 0. Okay? And that for this graph it is decreasing from 0 to infinity. Yeah? Now, you don't have to write it this way. I do this because I kind of get lazy. You can also write it, if you wish, negative infinity is less than x. So x is greater than negative infinity, but less than 0. It's the same meaning, it's just you wrote it differently. And here would be x is greater than 0, but less than infinity. Okay? But you cannot always assume that it is increasing from infinity or negative infinity to 0 or 0 to infinity, because in a graph you can have endpoints. And because of these endpoints, you're only restricted to this part of the graph. You can't go any further down. Okay, so it won't be infinity. Oh, this is poor lines. It would be, in this case, 4, and you can only go from negative 4 to, we'll put a 5. Let's draw this, make it more plausible. Okay? So then you change your entire interval of increasing and decreasing. Instead of having it from negative infinity, you would then have it at negative 4, okay, to 0, and 0 to 5. Okay? Well, that's how you saw it graphically. Pretty easy, huh? But in some situations you will not have a graph. You will have a function. And so how would you find if it's increasing or decreasing with a function? Well, you plug it into your graphing calculator, but this is calculus, so you don't need graphing calculators or a calculator at all. Okay? So we're going to do something called differentiating. We differentiate, we pretty much if you want formulas, follow this formula. F prime of x equals n x n minus 1. The n represents your exponent. And so what you would do is you would multiply your x by your n. And you subtract 1 from your exponent. Okay? Of course, if you have a constant, then you would also multiply your n to your constant. So let's differentiate this equation, this function. So we have f of x equals, well no, f prime of x, okay, equals 6x squared plus 6x minus 12. As you can see from from differentiating, you can take out a 6. So after you take out the 6, you're left with x squared plus x minus 2. So now what? Well, we're going to do something called the first derivative test. And this is a surefire way to find whether or not the function is increasing, or at which intervals the function is increasing or decreasing. In order to do this, however, we need to factor. So we will factor this. Okay? And we would get x minus 1 times x plus 2. Okay? Pretty easy. And we'll set it equal to 0. Okay? We set it equal to 0 and we find x. So that means x equals 1 and negative 2. Put a box around it, whatever. Alright. Now these points are very important, because they will not only help you find increasing or decreasing, but they're also your critical points, which will be discussed later by someone else or me. You know. So what you would do with these points is put it on a timeline. So go ugly timeline. Okay, I recommend putting dots at where you put your critical points. So here we put 1, negative 2. Now, it's pretty much an easy part, is to choose points greater than what your greatest point is, less than what your less point is, and something in the middle. So we'll go start with the middle, which is easy. We'll put in 0. Yeah, it's my preference. For greater, we'll go with 2, and the lesser point, negative 3. Okay? And what we would do with these points is plug it in to what we have for differentiate. We differentiate. Okay? We know that these two are 0, so you don't need to plug these in. You don't need to plug these 3. Okay? So we'll start out with negative 3. So it would be, from this equation, 6 multiplied by negative 3 squared minus 3 minus 2. Okay? You get 9. This would be negative 5. 6. This would be 4. 4, 6, 24. Okay? Now, this is a positive number. So wherever you had negative 3, or wherever your number you chose, you would put a plus sign. Okay? Next, we will plug in 0. So we would have 6 0 squared minus 0 minus 2. We're left with negative 2 multiplied by 6, and we get negative 12. Box it. Because we have negative 12, we would put a negative sign over 0. See? Then we plug in 2. So we get 6, 2 squared plus 2. Oh, this is addition, not subtraction. Minus 2. Okay, these cancel out. You have 4 times 6, so it's 24 again. Now, there we go. Now, what do these plus and minuses tell you? Well, they tell you where it's increasing and decreasing. For every plus that you have is where, so, like the interval on, if you graph this, okay, this function from negative infinity to negative 2, the graph is increasing. So negative infinity and negative 2, it is increasing. Okay? The negative represents decreasing. So decreasing a function is decreasing from negative 2 to 1. And you have another positive from 1 to infinity, and so the graph is also increasing from 1 to infinity. Okay? Oh, another thing. Do never assume that there will be a pattern with increasing and decreasing. Okay? Not always will you have a pattern of plus minus plus or minus plus minus. Sometimes it might not ever happen. So always check your points. Okay? Thank you for watching my video. Hopefully you've learned something new. Yeah? Have a good day. Goodbye.